So hopefully this section will be familiar. We actually did this in Algebra 1, and it's something that you have to do normally in any type of equation solving. So you would have done it in geometry as well when you were solving for certain variables. But the first thing we're going to talk about is just multiplying polynomials. Now remember, the term polynomial is just monomials, which is something like 2x. But they are put together by pluses and minus. So this is a trinomial. We have a 5x squared, a plus a 3x, a minus a 7. We have three terms that are added or subtracted. That is a polynomial with three terms. And so we're going to be multiplying polynomials. The first way is very familiar. This is really just distribution, and you did it in your bell work. And so when you have something like this, you are literally just going to distribute that outside guy through to all the inside ones. So we're going to say 2x times 5x squared. This is where your properties of exponents comes in handy. The 2 and the 5, of course, give us a 10, but the x and the x squared, when you multiply them, you have x cubed. And then you're going to do it to the next one, 2x times 3x. That's 6, and then an x squared. 2x times negative 7. It is minus 7, but you have to do your rules of multiplication. A positive times a negative is going to give us a negative 14, and then of course we have an x. That is distribution. So hopefully we are all very familiar with distribution. We have had to do it since probably middle school at this point. What we're going to do now is we are going to look at what happens when we have two polynomials, not just a monomial, one term, with a polynomial, multi-terms, but what happens when you have binomials specifically that we're going to multiply here. This is also something that hopefully you are very familiar with. This is called the FOIL method. You're basically just repeating that distribution. So when you have a two-term and a two-term, you're going to take the first term and distribute it through, and you're going to take the second term and you're going to distribute it through. The FOIL is just a way to remember it. You are multiplying your first terms, then you're multiplying your outer terms, then you're multiplying your inner terms, and then you're multiplying your last terms, okay? But you can look at it either way. It's the same process. First term distributed through, second term distributed through, and you are done. Now, if you have like terms in this process, you're going to simplify it after you have multiplied, which we're about to see. But once you have it simplified, you're pretty much done once you've multiplied it. So let's look at this example they've given us. They want us to multiply 3x plus 2 and x minus 5. So we are just going to multiply the first, outer, inner, and last terms here. So let's look at this one. So we're going to say 3x times x. That's going to be 3x squared, x times x. Positive 3x times negative 5 will give us negative 15x. Inner terms, we have positive 2 times an x, and a positive 2 times a negative 5. And so our multiplication is done. At this point, we want to look and see, can we combine anything? The 3x squared does not have a like term, so we're going to leave it alone. The negative 15x and the positive 2x are alike, so we can combine those for negative 13x. And the negative 10 does not have a like term, so we do not combine it with anything. And at this point, we are done. We have multiplied, we have simplified. So you'll notice the difference here is that we have a binomial and a trinomial. A binomial and a trinomial. So FOIL method doesn't really work, but it's the same concept. You're going to distribute the first term and distribute the second term. Anytime I have something like this, even if it has it switched with the 3-term in front and the 2-term behind it, I will flip it and I will always distribute that 2-term through. So for something like this, you are going to just take that 6a and you are going to multiply it through. So 6a times 9a squared, that's going to give us 54a cubed. Then we're going to say 6a times 4a, 24a squared. And then 6a times -7, -42a. And then we're going to distribute that second term. So we're going to take the -2 and we're going to distribute it through. -18a squared. -2 times 4a is -8a. And -2 times -7 is +14. So you can see that we distributed everything through. And then we need to combine like terms. So we are going to look for things that are alike. We have a 54a cubed, and you can see there's no other a cubed, so that's going to stay. We have a 24a squared and a -18a squared. So 24 minus 18 is going to give us a 6a squared. We have a -42a and a -8a. That's a -50a. And then we have a +14. And once you have it simplified, you are done. All right, so these are called special cases because you can see that they have a unique multiplication. And then when we get into the next section where we factor, you're going to have to go from the multiplied back. So we're doing multiplication in this section. In the next section, we're doing factoring, which is like doing division. And so it's nice to know these because you're going to need to recognize them when we start doing factoring. The first one is called the product of conjugates. So let's talk about that term conjugate. We will use that later as well. But a conjugate is something like this, same exact 2 terms, but you'll notice the middle sign is different. All right, the first term is the same, the second term is the same, but this is a plus and a minus. So it will always be a plus and a minus. When you have conjugates, one will be plus, one will be minus. But these will be the same. I do caution you, however, the a can be negative, and that's fine. It will be negative in the second group. The only thing that changes is the second term. So the second term, one will be plus and one will be minus. And these are called conjugates. And what you notice when you multiply conjugates is you get this first squared, second squared. You do not have a trinomial. We have been multiplying binomials and we've been getting multiple terms. 3 terms is what you typically get with multiplying binomials. That does not happen with conjugates. And so just to show you what it looks like when you do the foiling, if I were to say a plus b, a minus b, if I were to FOIL this just like we've been doing, we have a times a, that gives me a squared. A times negative b is negative ab. Positive b times positive a is positive ab. And then positive b times negative b is negative b squared. And you can see these two terms cancel each other out. One is positive and one is negative. So instead of having to FOIL them every single time, if you learn this shortcut, you can just square the first one. It will always be minus, and then square the second one. And that's how they will always FOIL. And what's going to happen when you factor is, when you see a perfect square minus a perfect square, you will recognize what it factors to. It will factor to the other side when you go from one way to the other. The other two are square of a sum and square of a difference. The only difference between these two is one is plus, one is minus. All right? And so if we look at these two and how they factor, you can first see that we have a plus b pretty much. It's just a plus b squared. So you will often see it written this way. What it means, that it means this. Multiply something by itself, right? That's what it means. This also has a shortcut because it will always do exactly the same thing. The reason you want to know the shortcut is when you start to factor. It's nice to recognize these factors. And so again, I would say a times a times b times a, and b times b. And you see for this one, the middle terms are exactly the same. So that's why it has a 2 in front of it, because when you add the AB and the AB, you get 2 times AB. And it will always do that. The only difference between this one and this one is your middle term is going to be subtraction for this one. All right, your last term will always be plus because you'll end up with a plus times a plus or a minus times a minus. But you will always end up with the first one squared, the last one squared, and the middle one will be these two multiplied and doubled, always. All right, and so these are conjugates and these are perfect squares. These are called perfect square trinomials. So let's look at the multiplication of these. If I were to do the foiling here, I could do the first, outer, inner, last, but I could also recognize that these are conjugates. So this is going to be the difference of two squares when I am done with it. So instead of foiling it out, all I'm going to do is I'm going to take the first term and I am going to square it. It will always be subtraction, and then I'm going to take the second term and I am going to square it. And so if I square 3y, I will get 9y squared. And if I square 5, I will get 25. And so I don't even have to FOIL it if I recognize that it is a special case. I can go straight to my special case. All right, let's look at the other two. This is a special case. So I'm going to say 3y, I will square that. This is going to be a plus, and I'm going to double what happens when I multiply these two, 3y and 5, and then my last one is going to be just my last one squared. And so when I do this, I will square this. That's going to give me 9y squared. 2 times 3 times 5, that gives me 30, and then I have that y in there, and then 5 squared is 25. All right, that's how that one will be. The only difference between B and C is that is a subtraction. So this one will look exactly the same as this one. They're the same things. I will square the first one. Now this is going to be subtraction of the 2 times the 3y times the 5. And I will square the last one, which will always be positive because it's squared. And so those are your special cases. And if you recognize them as special cases, you don't have to FOIL them out. You can go straight to your special case. Now, if you don't remember, let's say you look at it and you're like, I don't remember what the special case was. You can always FOIL it. But for these, you need to make sure you write them out because it does not just mean the first one squared and the second one squared. It actually means 2 of those FOILed. So if you don't remember the special case, make sure you at least write it correctly to do your foiling. I'd like you to try the special case because it's going to help you in the next section. All right, so let's try a couple of these.